In this lesson, we're going to continue our look at basic object inheritance. And this time, we're going to create our own subclasses, and we're going to extend the animal class. So go ahead and get basic object inheritance _ extension starter pack, and load that project into your Eclipse IDE so you can work along with me. You'll note there are two classes in the starter pack, an animal class and a driver. Now the animal class is modified to contain both name and breed, has the explicit constructor to take both, and has the set and get for both name and breed, and the toString with the name and breed returned along with the type of animal. We have three animals in the driver now: a default animal which has no properties, an animal with the name Fido and the breed dog, and an animal with the name Fluffy and the breed cat. And if we run this, it will print out exactly as we would expect it to, where we'll have our three animals printed out with their breed and their name. At this point, our system has been started, but let's say that we have a new requirement. And the requirement is we need to track the animal to see if it's a dog, if it has service animal status. Perhaps it's a seeing eye dog or a canine dog helping to search for missing people or drugs or whatever. So that would be considered a service animal. Or if it's a cat, maybe we want to determine, is it a house cat that has been declawed? Now, we could cram all of that into animal and continue to have more methods, and animal could continue to grow. But it really doesn't make any sense because we don't want our animals to necessarily have to check for things or have extraneous properties they'll never use. For example, we don't care necessarily if the dog has been declawed, and we certainly don't care if the cat is trained as a service animal. So rather than cram everything into animal, it makes more sense to create more specific objects, leveraging the superclass, which is the animal, that has the breed and the name already defined for us. So let's create two new classes, a dog and a cat. Now the first one we'll call dog. We'll actually use Eclipse to help us to stub out this dog class. So rather than our superclass being object, let's directly state that we want to be an animal subclass. So our superclass is animal. And it is going to be just a regular old public class, but we can actually stub in constructors from the superclass and any inherited abstract methods should they exist. And we could generate comments if we'd like as well. But what we see is as we create this dog, then we get our dog, which extends animal and has the two already stubbed in constructors, which is really handy. Now let's go create our cat object. And let's not inherit from animal. Let's leave this alone. And let's uncheck these so we can see this from the ground up. So here we see cat. Now the reason I want to do this is just so that we can exercise ourselves and see how we go about setting this extension up. So before we look at dog, let's go ahead and start looking at what we need to do at cat, and we can verify this will exist in dog as well. The first thing we want to do, if we want to inherit from another class, is we want to use the extends keyword. So we're going to type in extends, and here we're going to extend the animal class. Once I do that, if there's anything that has to be implemented, it would turn with a little red line, and then I could right click on that and say implement the methods. But right now there aren't any, so we're good to go. Our cat could actually be done, and we wouldn't need to do anything else. But let's create our two constructors, our cat constructor that does nothing, and by default, this is actually in place, but I'm going to type it in manually anyway. Super. Now that's just going to call directly to the default constructor on the superclass, animal. Now you don't need to type any of this if you don't have any constructor in place. This would be there by default. But we're going to define an explicit constructor, which is going to take in the name, the breed, and we want a unique property here, which is going to be is the cat declawed. So let's do this as Boolean. We'll just call it is declawed. Now, in order to track is declawed, of course, we need a private variable, and we'll just leave that alone and make someone set that in order to use it. And we want to set that, so we'll say is declawed equals is declawed. In order to use name and breed appropriately, you might be inclined to think, well, I just need to create two more variables up here for string and breed and then just set them, right? That's actually incorrect. The reason we don't want to do that is because name and breed are already defined at the animal level. And so rather than creating more memory use, creating extra variables that would be tracked separately, we want to leverage the base class or the superclass and pass those variables to it. Now we can do this again using the super keyword. And because the super constructor is already defined, we need to pass the variables to it in the same order we would expect to see them in the constructor. So we can look at the animal here for string name, string breed. So we're basically leveraging this constructor and setting those base properties for name and breed. Now ordinarily, we would also take the time to add in getters and setters to determine the is declawed. I'm going to skip over that for a moment. And the last thing I want to do is implement the toString on the cat. If we remember back from what we've already learned, the toString will automatically run, and if we don't do anything, it will just leverage whatever's there at the most recent level. So that would be the case where animal toString would be leveraged at that point. Just like we overrode the object toString in animal, we can override animal's toString in cat and dog. So here what we're going to do is return string.format again. So first I'm going to just say %s, and then I'm going to say /t, and then %s, and then another /t, and then %b for our boolean /n. What am I going to leverage? Well, the first thing I want to get is the super's toString. So I'm going to call super.toString. The next thing I want to get is the class that I'm currently in. So I'm going to say getClass.getName. And finally, what I'd like to get is whether or not it's declawed. Now, once again, if we had a get method, we would use that here, but we don't, so we're just going to leverage the variable directly. And I want to make this a little bit more friendly, so I'm going to say isDeclawed and %b. Now, our cat object has the toString and a constructor which sets the property and the isDeclawed Boolean variable. Let's take a quick look at dog. Dog also extends animal, and you see that it also calls to super, name, and breed. Of course, here what we'd like to do is add in the extra variable to track is it a service animal and override the toString. But first, let's go ahead and just look at the difference here between what's printing out. So let's create a dog, d equals new dog. Now we don't have anything set, so it has to take name and breed again. We don't have is a service animal set at this point. That's the best we can do, and we'll just print it out. We can create a specific cat now, and we have the better complex constructor for the cat, so we can actually pass in Fluffy as a cat, and isDeclawed, let's set to true. And then we can also print out the cat, and we'll see the differences in the different printing here. So we have our animal, which breed is null, null. We have the dog, Fido, the cat, Fluffy. But then we have the breed dog named Fido. Everything's set like it's supposed to be without even doing anything else. And the cat has the name, Fluffy, the breed cat, and it is declawed is true. And you can see also in here we have breed cat, name Fluffy. We had a new line here. Then we said cat, so this is the cat class printed out again. We will come back and continue our discussion of basic extension in the next video.